Bismillah ar-Rahman ar-Rahim. Welcome to another video session of M180. In this session, inshallah, I'm going to discuss the previous exam paper, the previous final exam paper that I have taken here, the last semester paper, that is Spring 2015. There are three parts in the question paper, wherein part 1 talks about the multiple choice questions, part 2 has some solving some problems and writing some methods to solve the problems. Okay, and part 3 has writing some codes, some Java codes related to the you can say related to the stack and the queues, and also there is some problem related to the trees, binary search tree, and in search the searching algorithms. Okay, sorting algorithms. Okay, now today inshallah I'm just going to discuss the part 1 and the part 2, which is multiple choice questions, and the part 2. Now starting with the part 1 multiple choice questions, the first question here is the time factor when determining the efficiency of algorithm is measured by what? We are not going to measure the time factor by seconds, or not by any statements, or not by the size, okay, of algorithm, but we are going to always measure the efficiency of the algorithm by its key operations. What are the main operations performed in the algorithm, the key operations that will be counted to determine the efficiency of an algorithm. So here the answer is D, counting the number of key operations. Number 2, how many cycles do you have in the following graph? Now how many cycles do you find in this graph? As you see here, there are 3 cycles. The first is, let's say, A, B, D, A, B, D, A. This is one cycle. The other cycle can be, for example, A, C, D, A. And the third cycle can be A, B, D, C, A. So these are 3 cycles you can find in this graph. Okay. So also you can write these cycles, for example, A, B, D, A. This is one cycle. A, C, D, A, another cycle, or A, B, D, C, A. This is the third cycle. So you have 3 cycles in this graph. Moving to question number 3, if we have a string S1 as drawers, okay, it is D drawers RS. We all know the string, it is in a set of characters. Okay, it has, every character has its index. It is starting from 0, 0, 1, 2, 3, 4, 5. Now it is asked you, this method, what is the output or the result of this method on this string S1? S1, this is the string S1. Now the substring methods takes the substring starting from the position what's given in the first parameter or the first argument, and including the fourth character, excluding the four characters but excluding the fourth character. Starting from 1, 4 characters but excluding the fourth character. Okay, now here you start from 1, that is R, A, W. The fourth character is excluded, so you should get R, A, W. Okay, so here it is, the answer is R, A, W. Moving ahead to the question number 4, says, what of the following does not relate to a stack? You see different options here. LIFO, it is last in first out. It is for the queues. Queues follow the operation of last in first out. Sorry, it is for the stack. I'm sorry, it is for the stack. LIFO is for the stack, last in first out, because the stack comes something like this. We are going to push the elements. The last element is pushed, is the first element to come. This is for the stack. Pile is again a data structure in which the elements are stored, okay, unorderedly. So this can also be done by using the stack. FIFO is first in first out. First in first out is a concept of queue. That is, whatever goes first, it comes first out. Okay, for example, A is inserted first, A is to come out first in first out. This is for the queue, it is not for the stack. So your answer is FIFO. So the answer here is FIFO list, which is not related to the stack. Moving ahead, question number 5. Which of the following represents data structures that store homogeneous data elements? Now, what is homogeneous data elements? It means all the data elements should be of same type, of same category, or you can say same type. So from which of the data structure will represent this? Records? No, records can have different types of values. Pointers? No, pointers can have different type of values, because pointer is just used to point to another. In pointers we are pointing, one element is has a pointer to another element, for example. So pointers will not have the homogeneous data elements. None of the above, but there is one thing called arrays here. Arrays, as we see the definition of the array, it is having a homogeneous data elements, or having the elements of same type, same name. Okay, that is called the array. So here the homogeneous data element data structure is arrays. Moving ahead, question number 6. Which of the following is a two-way list? Two-way list, it means doubly list, doubly linked list. Okay, so it is singly linked list? No, it is a one way. Circular linked list is again a one way, because circular is just a circular, but it is not in two way. It processes only in one way, in a circle. Singly linked list with a header and a trailer, no problem. Header and a trailer both are same. If it is a singly linked list, even if there is a header or a tail, it does not come in reverse. I mean, it does not traverse two ways. So it is none of the above. Then question number 7. The operation of processing each element of the list is known as traversing. That is, following or processing every element of the list is called, we call it as a traversing of the list, or we traverse the list. Okay, it is not called sorting, because sorting is arranging the elements. Merging is concatenating or joining the elements. Inserting, it means insertion of the elements. Whereas traversing, it means moving through all the elements starting from the first element. Okay. Then question number 8. Which data structure allows deleting data elements from front and inserting at the rear? It is queues, because in the queue we are going to insert from the front end and we are going to delete from the rear end. So this is your front end, this is your rear end in the queue. So it is, the answer is queue. Then question number 9. The in-order traversal of the tree will yield to a certain list of elements of the tree in a which format? In a binary tree, or in any tree, or binary search tree, or none of the above? It is binary search tree, because binary search tree the elements are in a sorted format. Okay, because in binary search tree we see that the elements, the root, from the root, the elements which are less will be on the left side, and which are the greater values will be on the right side. So we process the list from the left side always, either it is pre-order or in-order or post-order. We go to the from the left. Okay, so when you start from the left, you get the smallest elements, and ends at the right, we get the largest element. So it will be in a sorted list. Okay, so the answer is binary search tree. Now, what is the order of the step for a pre-order traversal of a tree? For this tree, what is the step for a pre-order? Pre-order, it means it goes from the root. First it processes the root, then left, and then right. So you start from the root. Root is 1. It is 1, then left 2, 3. So the order is 1, 2, 3. Okay. So these are some multiple choice questions given in the exam paper for the spring 2015. Moving ahead to part 2. The first question in the part 2 for 6 marks is, how does the merge sort work? State the necessary step. Now we have seen the merge sort. How it will work is, it will divide the whole S, that is the set of numbers or set of elements, into two parts. Okay, and it goes on dividing recursively. It will first divide it and call on the divided list. For example, S1 and S2, it will call again sort S1 and S2. When sort S1 and S2, S2 is again divided into 2 and S2 is again divided until you find a single element. Okay, and always the single element is sorted. So it goes on dividing. So the steps are over here. First, to divide partition S into two sequence S1 and S2 about n by 2. N is the size of the list. Okay, so n is the size of the list S. So you divide it half of it, so, and then you make two lists S1 and S2, and again divide recursively sort S1. So it will call again the divide and conquer and S2. So it repeats and all, and finally when it reaches only one element, no more elements, not more than one elements in every single list, then it starts conquering or merge S1 and S2 into a unique sorted sequence. While merging, it will be in a sorted merging, okay, or in ascending order merging. So these are the three steps for a merge sort, and this is how the merge sort will work. Okay, so related to any reasonable answer which is related to this will be accepted. Related, it means which explain the work, the merge sort work. Okay, coming to question number 2, what is the time complexity big O for the following codes? Now you see in the first code there are 3 for loops. Okay, one with a n, so it will give you a big O of n. The other with m, so it will, the big O is n into m. The third is with 6. Okay, 6 is a constant value, so we are not going to consider the constant value. So your big O is big O of n into m. Okay, clear? The second part, B, is for I is equal to 1, I less than n, I is equal to I into 2. Now what is the time complexity? See, it is big O of log n because the incremental value here is multiplied every time. So for example, it is 1 1, from 1 it will move to 2, from 2 it will move to 4, 4 to 8, 8 to, so it is not an increment of 1 or 2, it is an increment of multiplications. So any loop with an increment of multiplications or decrement of multiplications or the division, okay, multiplications or division will take log n, it will not take n, it will take log n. So here the time complexity is big O of log n. Moving ahead to the third part of this question is two different for loops. Two different for, one for loop with this statement, so it will take n because the loop iterates for n times, and this will take m times. Okay, so big O will be the maximum of n and m, max of n comma m will be the big O. Now moving to the question number 3 is about the tree. Given is an arithmetic expression tree, and it is asked you to find the in order traversal and post order traversal. Now first of all, what is in order traversal? In order says that first you process the left node, then the root, and then the right. Now you start from here in this tree. This is the root. The left of the root is minus. Minus is again a root for this subtree. Minus is again a root. So from the root minus, you go to the left is x. X is the leaf node. Now come back to the root. You process the root, and then you go to the right. So you process the left. You process the root, that is minus. Now you go to the left. Left is again a subtree which root is into. Okay, so from the root you go to the left because it says left root. So then you go to the left. Left is, now this is again a subtree. It has a root and has a left. Go to its left y, then process the root divided by and its right 5, and then go back to its root into, process the right 2, then go back to its root, then go back to the root plus. Okay, now we are moving to the root, main root plus, and then comes to the right. Right is a subtree having a root minus, then left of root is again a subtree which has a left z, root into right 5, and then the root minus and its right is 4. So this is your first thing. And the in order traversal, x minus y divided by 5 into 2 plus z into 5 minus 4. This is in order traversal. Now coming to the post order says that process the left and then the right and then the root, then the root. So you go to the left, right, and then root. Now if you see here, you go to the left is a root, again you have a left over here, left is x, then right is again a subtree. This right is again a subtree which has a root. Go to its left is now divided by, this is again a subtree, it has a left y, then right 5, then the root divided by, then its right, the right to this divided by is 2, then the root multiplication, then the root minus, and then go to the right of it. Right is a subtree, has left into is again a subtree with this is again a subtree, has a left z, its right is 5, then the root is into, then its right is 4, then its root is minus, then the final root is plus. So this is your the post order traversal, x y 5 divided by 2 into minus z 5 into 4 minus plus. So this is how you are going to process it. So this one I have explained in another video which is already there on the YouTube. I have uploaded. You can access this that video. I mean you can access that video to have more example, to understand it very clearly if you have not understood with this example. Okay, moving ahead to question number 4. It's about the linked list. Now given is the linked list consists of nodes with the sorted numbers in an ascending order. Okay, draw the result after executing following statement applied in the same order below. Node P1 is equal to first dot next dot next. Now what is first here? This is here first. The list is not clear here, I believe. Yeah, this is your first. Let me just take enter the elements of the list. Yeah, the given list is this one with the value 2 here, and then 4 here, 5 and 7. Okay, this is the list, and the first is the first pointer. Okay, now it is telling the first statement. What is the output after, or what is the list after executing this statement? The first statement, node P1 is equal to first dot next dot next. So first dot next is 5. So 5 over here, this is P1. Okay, this is the list after executing A. Now let us take B. Node P2 is equal to new node. It is a new node created. So it is a new node over here with the value 6, and the link is to P1 dot next. P1 is this one, next is this one, P1 dot next. So it is referring to the here again. Okay, now this is for B. Now for C, P1 dot next is equal to P2. P2 is this one which is newly created. P1 dot next is this one. So you have the list. This will not be there. You have 2, 4, 5, 6 and 7. Okay, so as you see over here, it is initially 2, 4, 5, 7. This is 6. This will be 2, 4, 5, 7. This is in B, where you create P2 and your p2 dot next is equal to p1 dot next, which is this one. Okay, this is p1, this is first. Okay, now after that you said in C p1 dot next is equal to p2, so you are making this over here. Okay, so your list will be here 2 4 5 6 7, and this is your first, this is p1, and this is p2. Okay, this is the first part. The second part says that suppose that a Java method insert node takes a sorted list L, insert the value 6 in its proper position. Okay, you are asked to rewrite the method below on your answer booklet, missing the following parts. Now you have to, the question here is you have to insert the value 6 in its proper position in the list. In the list is the proper position of the 6 is here, right? Because after 5 the proper position is 6. Now you have to go on finding the value until it is less than 5. You are going moving the nodes until you find the value less than. Once it is greater, you insert at this point, and once you find the data greater than 6, you insert the node at this point. So what you have to fill over here is the moment will be up to you find keep on the moment of nodes, I mean the pointer from 1 to first to second, second to third. Okay, up to the until the value of the or the data of the node is less than 6. So here what you have to put is p is equal to L dot first, so here is p, so we are going to move p. So p is p dot next dot data is less than 6. Okay, then you move again, I mean move the p. Okay, so p dot next dot data is 4, which is less than 6, then you move p becomes here p dot next dot data is 5 less than 6, then you move p over here. Now p dot next dot data is 7, which is not less than 6. At this point you don't move it. Okay, at this point you are going to, what you are going to do, you are going to fix the insert the new node 6. Okay, so you create a new node at this point with a 6, and the next pointer is p dot next. Okay, p dot next will be 6. Okay, now you see here for the loop there is a semicolon. This will not allow to execute this until it will finish. Okay, so once it will become false, it will come out of the loop and do this job. So as you see over here. Then the next is about the graph. Given is a graph adjacency list. So here you have, let G be a graph whose vertices are integers from 1 to 8. Okay, the vertices are from 1 to 8. Let the adjacency matrix is this. This is the adjacency matrix given. It means the vertex 1 is connected to 2 and 4. 2 is connected to 1, 3, 4. 3 is connected to 2 and 4. 4 is connected to 1, 2, 3, 6. So 5 is connected to 6, 8, and so on. Okay. Now what is the question here? The first question is draw graph G. Now for this adjacency list you need to draw graph G. Let us take a start from 1. I'll take 1 first. 1 is connected to 2 and 4. So I'll put 1 with 2 and with 4. Then 2 is connected to 3 and 4. So 2 is connected to 1, 3. 1 it is already connected. 3 is not connected, so I will add 3 here. Okay, and 4 will be this one. Okay, then okay, then from 3 is connected to 2 and 4. It is already connected 2 and 4. Okay, 4, now vertex 4 is connected to 1, 2 is already connected. 3 is also connected. 6, now I'll take 6 here. 4 is connected to 6. Then 5 is connected to 6 and 8. 5 is connected to 6 and 8. So let me take 5 over here. It is connected to 6 and it is connected to 8. Then 6 is connected to 4, 5, 7. 6 is connected with 4, connected with 5. Now connect with 7. Okay. 7 is connected to 6 and 8. 7 is connected, already connected with 6. Now you connect it with 8. Then 8 is connected to 5 and 7. 8 is connected to 5 and 7. Okay, done. So this is our graph G according to this adjacency list. Moving ahead, the second question is order the vertices as they are visited in DFS starting at vertex 1. Start from the vertex 1 and apply the DFS, that is depth first, okay, traversal, and write the order. Now you start from 1. DFS says that you start from 1 and go to its nearest neighbor, okay, and then keep on moving, okay, by visiting the neighbors until you reach the last. Okay, now let us start from 1. Its neighbor has 4 and 2. 2 is the smallest. Let us take 2. 2 has 3 and 4. Let us take 3. 3 has a 4. Let us take 4. 4 has 6. 6 has 5 and 7. 5 is the smallest. Let's take 5. 5 has 8. So 8 has 7. 7 has 6. 6 is already visited. Then you come back. So all the nodes are visited. So the list is this one: 1, 2, 3, 4, 6, 5, 8, 7. 1, 2, 3, 4, 6, 5, 8, 7. Okay, you follow it, DF, that is the depth first traversal method. So this is all what we have for in part 2 in this paper. Okay, so the next part is part 3. So inshallah in the next video soon you are going to receive the next video in which I will discuss the part 3, that is having some programs and all that I will discuss inshallah. Okay, thank you for watching and all the best for your exams.